Alright guys, last video got cut off, but to continue on with this problem, we would get x squared minus 13x equals 64, then we bring this 64 to the other side. The final step in these problems would be to either factor or use the quadratic formula. Now in this case, you do have to use the quadratic formula to solve. However, I didn't make it as complex for the problem I left for you guys to solve. The problem you guys will have is factorable. Alright, so from this step, we're just going to factor and solve. Okay? Moving on to the last set of problems. This involves your compound and simple interest formulas. Okay? You might want to go ahead and review those formulas as well. What they look like, 1 plus R stands for N, and A equals P e to the RT. What these variables stand for, remember, are P stands for principal or the initial amount you invested. R is the rate or the interest rate you have. N stands for how many times your money is compounded in a year. And T stands for time. Over here, E is a number, but it's on your calculator. It's just it's a set amount. We use this when it's continuously compounding. R still stands for rate. P still stands for principal, and T still stands for time. So in our first problem, number 17, you deposit $4,000 in a savings account. That pays an interest rate at an annual rate of 0.5%, compounded monthly. I'm going to underline that word monthly. It's going to be important for us. How much will you have in your account after 3 years? So the equation we're going to set up is A equals 4,000, or the initial amount we invested. A stands for the amount of money, by the way, times 1 plus, now my rate, notice how I'm going to write this. I have to express my rate as a decimal, not a percentage anymore. So I'm going to divide by 100 to convert that into a decimal, 0.005 over 12. Think about where that 12 is coming from. 12 is coming from how many times it's compounded in a year. It's compounded monthly, well, 12 months in a year. It's compounded 12 times in that year. So this is the equation we have set up. From here, this is where you probably want to go into your calculator at this point. We might want to do this inner calculation first. 0.005 divided by 12 plus 1 raised to the power of 36. You simplify 12 times 3. We're going to have to round when we solve. We round to the nearest penny because we're dealing with money. We're actually going to have $4,060.44. All right? 19, we have the similar setup of this problem. However, now we're compounding continuously. So that means we're using the formula A equals P e to the RT, or PERT. All right, some of you guys like to say. We have still our initial amount invested is 4,000. Remember, E is on your calculator. E is just a number, okay? Special number. The rate we're going to convert to a decimal, and we're going to have it still times 3 for 3 years. Just to recall, we have to apply the order of operations. For the order of operations, what you should be doing is I should be simplifying 0.005 times 3, and then e to that power, which is 0.015. Then times 4,000. All right? I would get, after 3 years, I would have $4,060.45, which makes sense. Our compounding, because notice it's about the same value, same interest rate from problem 17 to problem 19. Very similar. We only earn one more penny, but hey, we got a little bit more money out of it. So it's a better deal, I suppose. So just pay attention to, for your interest formulas, what formula we're using. This is continuously compounding. This is everything else. Okay? These formulas are provided to you, but you guys should be memorizing what those variables represent and how to use them. Okay? If you guys have any questions, feel free to reach out to me and prepare yourselves for tomorrow's exam.